Dear students, in second unit we are showing what are the design parameters for cylinder, piston, cantilever, crankshaft. First, today we see out what is cylinder design. First of all, before design, the material selection is very important. In material selection, what are parameters to be considered is thermal resistance, wear resistance of the cylinder material, corrosion resistance, strength. These are the basic materials, and also the capacity of the material to resist the pressure and temperature. These are the main characteristics of the cylinder materials. These are some of the reasons for piston failure: lack of oil pressure due to faulty of oil pump, burnout, damage bearings, can be not poor oil quality, blocked oil jets. So some of the parameters you can consider while selecting a material is very important, because it can help to withstand the temperature as well as pressure. Because the IC engine operates at an elevated temperature of around 300 to 400 degrees Celsius. So we can ensure the material that does not deform anything before it will. Suppose it deforms, it will create a lot of problems. It's a basic problem. So before designing, these are the parameters we want to finalize. The power capacity of the cylinder to be developed at the speed of the RPM, and the clean effective pressure, the efficiency. Suppose these four data will be required to design the cylinder. Suppose these are the given data, the required data for designing the cylinder. The first we have to find out the indicating power. The indicated power is equal to brake power divided by efficiency. We can get 6250 watts for this particular problem. Next, we find out the cylinder diameter. Cylinder diameter IP is equal to, the formula is mean effective pressure into length of the cylinder into area of the cylinder into number of strokes divided by 60. We can get the value of, when substituting these values, we get the cylinder diameter 115 mm. So this 115 mm is able to generate a power of 5 kilowatt. That is the thing. After finding the cylinder diameter, we can next find out the thickness of the cylinder, because thickness of the cylinder is also very essential, because the thickness of the cylinder we can, if it is less means it will burst or it will break. So next we can, after finding the diameter, we can find the thickness of the cylinder. Thickness of the cylinder is equal to diameter of the cylinder into C into P divided by sigma T. C is equal to 0.1 is constant, always it is like as C. P is equal to pressure inside the cylinder. The pressure inside the cylinder is always equal to 10 times of the mean effective pressure. So we can substitute sigma T is the material stress allowable by the stress of the cylinder material. We can design. So there are three materials nowadays. One is cast iron, second one is alloy steel, third one is aluminum. So depending on our requirement, we can change. We can use this sigma. This parameters for cast iron, 30 to 50 Newton per meter square for cast iron. So we can substitute this here, means we can get the cylinder thickness. In this problem, we can get approximately 10 now. The next parameter is find the size of the stud, because the cylinder head is connected with the cylinder by using studs. The stud is also very essential. Suppose if stud failure means it will open the cylinder, so it will all the exhaust gases and the steams comes out from the cylinder. So finding the stud diameter is also very important for stud. But finding the stud diameter, calculated by using the two parameters. One is first find out the force acting on the cylinder head is equal to, by equating these two parameters, we can be able to find out the stud diameter. First one is force acting on the cylinder head. Second one parameter is resisting force offered by the cylinder stud. So this, by substituting these two values, equating two values, we get the stud diameter. By equating the equations 1 and 2, we can be able to get the stud diameter is 10.98 mm, almost 12 mm standard size. The maximum width minimum pitch is calculated by using the standard is calculated by using these formulas. So these are some of the major parameters designing procedure. So always while designing a cylinder, we can be able to give these both data, the amount of power required to develop maximum speed of this engine, and another is mean effective pressure,